Hello. Welcome back to the continuing lecture series in investments. So in our last session, we discussed and defined the covariance and the correlation. Okay? So mathematically, correlation is the correlation ranges between -1 and +1. If there is a perfect correlation, it would be +1. If there is a perfectly negative correlation, it will be a -1. And if correlation coefficient is 0, that means there is no correlation whatsoever. And so mathematically, correlation is defined as covariance over standard deviation of x and standard deviation of y. Now, I also normally also talk about this in Finance 100, not necessarily because for the sake of correlation only, but because I also talk about correlation because it's inevitable in even in Finance 100. But then I also talk about how correlation is calculated. In other words, the formula for correlation coefficient. But together with correlation rho, right? Correlation coefficient rho, there is also a correlation coefficient beta. I mean, think about it. You must remember what, you must remember beta from Finance 100. And when because we talk about CAPM in Finance 100, so it's inevitable to talk about beta. But and probably not too many people remember what not too many people remember beta as correlation coefficient. They just think, probably you just remember it as slope coefficient. Yes, of course, it's slope between x and y, between a dependent variable and an independent variable, and dependent variable being y and independent variable being x. And to find beta, we have to use a statistical process called regression. Therefore, the independent variable is also called regressor, and dependent variable called regressant. What I'm trying to say here is, look, if rho is correlation coefficient and beta is also correlation coefficient, how are they different? And for now, because our two variables are stock and bond, that's why the subscripts are S and B. Just permutate them with X and Y. I mean, random variable X and Y. Well, what's the biggest difference between, X and Y and S and B? I mean, that's just a symbol, right? For, two random variables, right? But is X and Y really random? When we find correlation between stock portfolio and bond portfolio, there will be some correlation, definitely. And the correlation may, as I said, correlation would be slightly negative, right? Correlation, because it's a known fact that when bond market is when bond market is not doing that well, stocks are doing well. I mean, actually, there can be a positive correlation when, but think about it. If bond market is not doing well, what does that mean? The return on the bond is not that high, right? Return on the bond is not that high. If the return on the bond is so, in other words, return on the bond is what? Return on the bond is basically the basis of the interest rates, right? So if the return on the bond is low, and then that means borrowing is cheap, right? Because interest rates are low, and then when borrowing is cheap, what do? You borrow cheap and put it into stocks, right? And also when return on the bond is low, there's no reason to put your money into bond or lock it up in lending, right? So why do they drop the interest rate? Why does the Federal Reserve, drop the interest rate, hold it there for such a long time whenever there is a recession? They want to pull it out, right, by stimulate borrowing. If the borrowing is done by the real sector, that would be good. It will create, it will expand the production capacity and create jobs. But and when the economy isn't physically growing that much, right? If the real sector isn't growing that much, borrowed money goes all into the stock market. Of course, the money borrowed at cheap rate going into the stock market is also fueling the real sector as well, because through stocks they raise capital and invested in expansion, right? So it's not totally unrelated. But what I'm trying to say is, if the real sector has hit the plateau of growth, right? And it only just overheats the economy. Right? I mean, it will just result in inflation. And stock market is always usually in inflation, because when interest rates are low, they borrow cheap, and then put it into stock market, regardless of the growth potential. You know, um, the growth GDP, potential GDP, which is the gap between the you know, uh, pot- uh, uh, the potential growth and actual growth, regardless of whether there's a growth potential real sector potential for growth or not. They put it into stock. But anyway, the idea is bond and stock there's a correlation, certain correlation, but the correlation is generally negative. But it's not like one thing is causing the other, right? In other words, they are both independent variables, right? They are both random independent variables. Okay, there are certain correlations, but they are not. It's not like correlation is running both ways, not just not one way, right? Whereas what was CAPM? CAPM is the correlation between basically the correlation between the stock market and stock market's risk premium, market risk premium, and individual risk premium, individual stock risk premium, right? That's basically so I don't want to spend too much time on this to cut it short. Beta is a correlation, but one is dependent variable and the other is independent variable. In other words, y is always symbol for dependent variable, whereas x is the symbol for independent variable, and y doesn't change spontaneously. Y doesn't change on its own. The change in y is caused by change in x. That's why one thing is dependent variable and the other thing is independent variable. It's not. They say it's not causation. There's a difference between causality and correlation, right? But the effect of change in x, right? Clearly, a change in x has an effect on change in y. That's why they are called, dependent variable and independent variable. And the correlation runs mainly, from x to y. Okay, not vice versa. So in that case, that correlation is captured by beta. Okay, rho is the correlation that runs both ways. But in beta is a kind of one-way correlation, you can say. Now, so how is then beta calculated? It's the same thing. Beta is calculated by pretty much the same structure. This is covariance, right? I don't want to. Okay, I didn't want to write covariance, verbally like that. This means covariance. Okay, and then over variance of x. Okay, so what's the difference? It's the covariance, right? And then in rho, a standard deviation of x times standard deviation of y. And in case of beta, it's just the variance at the bottom, right? Now, anyway, if rho is defined this way, then the covariance can be defined as rho times, right, standard deviation of x and standard deviation of y. Just the same then, covariance in case of beta, right, if correlation is one way and is captured by beta, then the covariance is basically beta xy, beta of x and y between x and y, times variance of x. Okay. Now, so with that in mind, let's do this example. I mean, this example is not, nothing new. We remember this example from, chapter 5, right? We remember. But this time we are, we have, a stock portfolio and bond portfolio, right? And we will find weighted average of, if weight is, right, weight of the stock portfolio is 40%. If the weight of the bond portfolio is 0.6, right? So we're going to find, risky portfolio, expected return on the risky portfolio and the standard deviation of the our risky portfolio and the covariance and correlation between, stock and bond, stocks and bond, or stock portfolio and bond portfolio. Okay, so basically it's easy, it's something you've done already before. So all you need to do is simply, okay, keyboard is sticky. Well, we know, probability times, if you're holding, it's a stock portfolio, right? Okay, and I will, and then we know what is the expected return. I remember it to be 10%, but we can easily, just find, auto sum. Okay, and there you go, 10%. And then we want to take the difference terms because we want to find standard deviation, so we have to find the deviations. Because basically the return minus expected return, and then we'll lock it because we're gonna lock it. Oh, maybe you're not. I'm sorry. So I'm gonna have to stop sharing this, and yeah, okay. You're saying it just about now. There you go. Okay. All right. So this file is, of course, the same file we used in chapter 5, risk and return, but also you can find this file in the our current, topic folder, right? Now, again, so I'll have to lock it. So, and then I will drag it down, and then to find, variance, it's probability times the difference term squared. Okay. All right, then find sum, model sum, and standard deviation is square root SQRT of this. And if I remember correctly, it was like 18 something, 18.63. So this was, exactly, what we did in the last exercise, right? Nothing new. But this time we have also bond portfolio, right? So we do the same thing for the bond portfolio to find its expected return and variance and standard deviation. Remember, we're constructing a risky portfolio with 40% weight in stock and 60% weight in bond. So here, for our bond, it's to find expected return on portfolio, we do the same thing. Probability times and bond is bond return under this scenario, right? Severe recession, mild recession, normal growth. These scenarios, this was given, right? So there you go. You do that and you drag it down. There you go. And then by using auto sum, you find the expected return on the bond portfolio, which is 5%. Yeah. Then we need to take the find the difference terms or deviations, which is basically this minus, right? The expected return on the bond, and you lock it by hitting F4, right? Lock it by hitting F4 so that you can drag it down. Now it's the same, I'm going to copy and paste the whole thing because it's the repetitive, process, the same process. No, I better not do that because if I do that, then it's going to be pointing to the probability won't be, correct. So even if it is a little, tedious, let me do it, like this. Probability times difference term, right? Squared. And then I'll drag it down. And this I can copy, So there you go. Our bond variance of the bond portfolio is this. The standard deviation of our bond portfolio is this. And last but not least, a little housekeeping. The borderline thing. Now, bond and stock portfolios have, separately, right? They have, 10% expected return and 5% expected return, respectively, and standard deviation of 18.63 and 18.63 and 8.27, respectively. But if we construct a portfolio with, risky portfolio with bond and stocks and bonds with these weights, then we'll have to, our holding period return will be, we'll have to apply this weight. Oh, so I think having I thought that will. Okay. So here, I'm gonna have to apply that weight. Okay. And then times Stock's holding period return, and I'm gonna have to lock into that weight, and then plus the bond. I will lock into that because I'm gonna need it repeatedly times the bond return under severe recession. There you go. And then I drag it down. Okay. And then to find the expected return on our risky portfolio, and I weight them by probability. And I drag it down, and using auto sum, okay, find, and I get this, right? And then to find the variance, I'll have to take the difference terms, and the difference terms will be this time. This is the holding period return, and this is our expected return on the risky portfolio. And I'm gonna have to lock it because by hitting F4, right? So I'm going to let's drag it down. And there you go. And then to find variance, multiply that by difference term, probability, and square. Drag it down. Okay. And then using auto sum, I find variance. And the standard deviation is simply the square root of that. Now I have found the expected return on our risky portfolio and the standard deviation on our portfolio. Now you can tell already the standard deviation has gone down. Right? In other words, the risk is, risk has been reduced a lot. Risk has, if it was stock alone, right? Stock alone, the risk would have been much higher. Even the bond, right? Bond alone, bond portfolio alone, standard deviation was slightly higher. But when you combined, stocks and bonds, stock portfolio and bond portfolio, by these weights, right? The expected return on the portfolio is somewhere in between, right? But the added benefit is variance is not somewhere in between. The variance is actually lower than individual cases, right? Both cases, respectively, both portfolios, individual portfolios, respectively. So I reduced the risk, right, by constructing, a risky portfolio, right, with stocks and bonds by that weight. And depending on the weight, if the weight was, the opposite, then probably, our standard deviation probably didn't benefit that much. I'm going to find, covariance. So to find covariance, I will need, what's the covariance? Basically, I want to go back to let me quickly let me see if I can copy this. That's going to be a okay. I can't copy that, so I'll just basically you will see later covariance is what do we need to do? Covariance with x and y is what? Instead of sum of squared, it's xi minus x bar times y I minus y bar, right? So difference terms, right? Product of the difference terms, and will be n minus 1 if no probability is under uniform probability. If probability is not that relevant factor, right? But if it is with probability, then we know it is probability times, right? It's weighted by probability. So here, we need exactly that. So the difference term of stock fund, right? Stock fund, bond fund, right? Okay. So basically, but we have that already. Difference terms, we have them already, right? Difference terms are here. I'm gonna, and here also the difference terms for the bond put difference terms here. I'm going to drag them down. Okay. And then product, right, of these two difference terms. So it's this times this. I'll drag it down. There you go. And then probability, we weight it by the probability. Probability times, because instead of dividing it by n or n minus 1, right? Because we have different probabilities, we cannot do it like this, but we have to weight it by probabilities, right? And this is already a product, so it's like a squared term, right? Like in variance, it's like squared term. And there you go. I drag it down. And the covariance is using, just like variance, using auto sum. And there you go. That's the covariance, and it's negatively correlated. It's not even slightly negatively correlated. The correlation is almost like 75%, negative 75%, negative, right? But they go really in opposite way. Stocks and bonds are, going in opposite way. Okay. And then the correlation is what? Correlation is since I cannot go back to the switch to the PowerPoint, let me quickly correlation between, that's not P, that's Greek character rho. Correlation between X and Y equals covariance of x and y over standard deviation of x and standard deviation of y. Okay, so we're going to do exactly that to find the correlation. And since covariance is negative, correlation will have to be negative, right? Because this thing is negative. No matter what this, unless these two are negative, then this will be positive. But standard deviation by themselves, standard deviation of stock per se and standard deviation of bond portfolio per se cannot be negative. They will be positive both. So the whole thing will be negative. So basically all I need to do is I divide it by standard deviation of stock and standard deviation of the bond. I do that, what I get? Yeah, correlation is almost 0.5, right? And let's compare that result with our. So I'll have to. So everyone is okay with that. So I will stop sharing and Excel and start sharing once again the PowerPoint. And so we did this, and the correlation, right? That's the covariance. And this is not, they're not using percentage here. But if it is in percentage, that is what we got, negative 0.748%, correlation negative 0.49, and check the standard deviation of the risky portfolio that we got. Yeah, we got 6.65 for standard deviation, and that's percentage, right? Again, expected return, percentage, right? Okay, 7%. So that checks out. It confirms our. It completely checks out, right? Confirms our result. Okay, so that's it for this segment of the video. That's it for this session, and I will see you guys in the next video. Stop recording.